this video, we're going to go over using the Texas Instruments scientific calculators. I've got one here, and how to use them to enter scientific notation. There's a special warnings on this because there is a strong possibility of some errors when you use them, and I want to warn you about them. Well, first of all, there's a little bit of variation on the TIs. There's a TI-34 scientific calculator that I have here, and then there's the TI-30Xs that are here, and also we've got the 30Xs with a Pro and Plus. The Pros and the Pluses have a EE button for scientific notation. Let me clear this. 4.5 times 10 to the negative 3. And that's it. That E stands for times 10 to the negative 3. Here you can see it's decimal equivalent. And if you want to go over this and look at it more carefully, this is the same method as using the TI graphing calculators, except you don't need a second function to get to the EE. There is no problem. This is a times 10 to feature, which is very nice. This also works for the TI-30Xs, where you've got an EE button that stands for times 10 to. So no problem there. However, I'm going to spend the rest of the time using the TI-30XS, and the same applies to the TI-34 multi-view. And I'm going to be going over that because this is something that you've got to be very cautious about. As I say, if you've got an EE button, fine, use that. There are no cautions. Here we've got some special warnings. So let me go through the problem. You'll see where the warning shows up. I'm going to use the chemistry problem. It's a pretty typical one. It uses scientific notation. Don't worry about the chemistry. Just worry about the calculations that are involved. We're going to go over the calculations that are involved to find out, in this case, this problem where we have yellow light, which has a wavelength of 565 nanometers. Its little photons have got that length, 565 billionths of a meter in terms of size. And we're going to find ultimately the energy of a single photon of one of these light quanta. Now, the secret to solving this is in using a couple of equations that you'll find on the AP exam. The energy is equal to Planck's constant times a frequency, which is nu, and then this other one. In this problem, you'll see that we don't have a frequency. We've got a wavelength, so we've got to bring in a second equation, which allows us to calculate the frequency. Here you can see nu is the frequency, E is the energy, and this is what we have, the wavelength. So we'll use this first equation that uses the speed of light given on the equation sheet, the wavelength which we've been given of yellow light, and we're going to calculate the frequency. So on to the problem and using the calculator for it. Again, we've had the equation here. We'll rewrite the equation algebraically, so we're solving for this nu, the frequency, and we're going to have to put in the speed of light. And that speed of light is given on the equation sheet, but you should remember it to 3 times 10 to the 8 meters per second. The equation sheet gives it to 4 significant digits, which is a bit excessive, but hey, they put it in there. And it is meters per second. So you can make it almost to the moon in 1 second if you're riding on a photon of any wavelength of light in a vacuum. And we're given the wavelength here, which is 565 nanometers. So we're ready to start plugging things in to solve for the frequency. And you see I've got the plug-in, but immediately you should see is a problem because we've got a nanometer in a denominator and a meter in the numerator. So this n is going to have to be taken care of. That n stands for billions. It's a prefix. And so this is 565 billionths of a meter, and written properly to solve this problem correctly is to use 565 times 10 to the negative 9 meters. So we've got our calculation, and this is one that you'll want to use a calculator for. Now I'll bring that up. I'll drag that calculator over so we can see the calculation. You would have written this down on your FRQ so you could then type it into your calculator. Numerator, no problem. I could have typed in just 3, but let's be compulsive and make it 2.998. Now we're going to have to put in times 10 to. Now there is a times 10 to button here. This is the one that produces scientific notation in the 30x and the one of the multi-views, the 34. This would be the E button, the exponential entry button that you would use on the other scientifics. In this one, when you press it, you get this, times 10 to. That looks very nice. That looks a lot more efficient than the E, but there's a problem with it. Now, I've got 8, so that's fine. Now, be careful. If you continue to type in anything else, even a multiplication or addition sign, it's going to be coming into this exponent of 10 to the 8. So you're going to have to use the right function here to get out of that, so you're doing the regular calculations. So it looks pretty good. We've put this number in, a very large number, quite a few meters, like I say, almost to the moon if you do this in meters, and you'll do that in 1 second for light. Now we're going to divide that, and I did this the first time, and this is where I found the problem. I typed in 565 and then put in scientific notation, and then here the -9, don't use the subtraction button. This is the subtraction button. You want the negative button, -9. And then I said, okay, that's it. I'm ready to do my calculation. However, there's a problem because you're going to get the wrong answer. I mean, it looks right. You've got the 2.998 times 10 to the 8 divided by 565 times 10 to the -9. Now, when I look at this answer, and this is one of the cautions they should always have when you use a calculator, you got to make sure your answer makes sense. First of all, you could be putting in something wrong, as I did here. And this is wrong. You should think when you're using your calculator. I mean, a calculator will do the calculations that you put in it, but you really, really have to think. And I'm saying here, I've got a large number, millions, and a very, very small number, millionths. So I'm going to get a large number for an answer. And this is what I got for my answer. What? This isn't a large number. Not even close. I said, what's wrong? What's wrong? Well, what's wrong is that when you do this, their set of their scientific notation is really a multiplication times this power. This isn't here. When you do this, you're saying, okay, this is all one number, and the E button makes it one number. But there's a flaw here, because really what's going to happen is you're going to go 3 times 10 to the 8th divided by 565, and then times 10 to the -9. So you're not dividing by the 10 to the -5, the scientific notation part of the question. So this is going to give you the wrong answer, and obviously it's the wrong answer. And here's where the caution is. When you're using scientific notation, using these TIs with their funny times 10 to button, rather than the E button, you're going to have to make sure that you use parentheses. Now, I don't have to use the parentheses for this because it's just the multiplication. So I'm not going to. But if, there's an error, I'm going to have to go back and do a delete. And then I'm going to do in fact, I'll go delete, and I'm going to put in times 10. I'm going to have to do a lot of deleting. So I'm going to go back here and put in the times 10 to, and now I'm going to put in 8. Now I'm going to go to my next thing. This is a bit awkward. Divided by. But you're going to have to use, whenever you do a division with a scientific notation using these 30s, you're going to have to use parentheses. Now, 565 times 10 to, and then my negative, remember, don't use the minus sign, 9. I'm going to go to the right. You may not have to use this parentheses to close it, but I'm going to do that anyway just to be extra careful. So whenever you're using the scientific notation, make it stick to the number by using parentheses. Otherwise, you're going to have some difficulties. You'll get some wrong answers. If you're using a 30x with this sort of thing, practice, practice, practice to make sure you're using it correctly. So I'm going to enter now, and we should get a large number. Let's see. Oh, yes. Here we've got a large number, 5.306, who cares about that, times 10 to the 14. That makes sense. You've got very, very, very small wavelengths going by you at the speed of light. So you're going to have billions and billions of photons or waves going by you each second in yellow light. So that's our answer for this part of the question. And again, a caveat, use parentheses when you're using these 30x's and their scientific notation. We want to get the energy of the light, so let's go this next step and use our calculator again. We're going to use the energy is equal to Planck's constant, this beautiful H. It's got sort of an interesting reason for us, that H. It was a German word that says this isn't going to be an important constant. And when Planck was figuring this out, it's going to be like a throwaway constant. It was going to be 0. But he found out instead it was the secret to quanta, one of the major discoveries of this 20th century. He got the Nobel Prize for it. And that is on the equation sheet. We've got Planck's constant here, which is now used as a definition for determining what mass is even. So it's a very important value. It's now defined to a certain level. But let's get back to our calculation. And we're going to have our Planck's constant 6.62 times 6.626 times 10 to the negative 34 times our frequency. So let's get the calculator out again. I've got it here. And don't clear things out of your calculator. This was our last answer, which was the frequency. I'm going to take this 6.626 times 10 to the negative 34. I'm going to multiply it, so we don't have to worry about parentheses. Again, go to the right, times, and don't type in this long answer up here. If you're like me, you're going to make a mistake. You're going to type it in incorrectly. There's a key button. You should do your calculations sequentially. And this is a natural sequence. We just figured out frequency, and this is the answer. And it's there. So look here. Here is second function answer. This was our last answer. Again, we'll think ahead of time. 10 to the 14 times 10 to the negative 34. Okay, we're going to get a small number, which you expect for a single photon of yellow light. Let's see if our answer is small. And this is always our last answer. Enter. Indeed, we get a very, very small value, 3.51. I mean, who cares about these other numbers, times 10 to the negative 19. So that worked. Now, this is our new answer. You could have just taken originally this answer and just typed in times and then 6.626 times 10 to the negative 34 in terms of sequential, but because I had HV rather than VH, I thought I'd do it this way. This is per second, so the seconds cancel out. Our answer is going to be in joules. This is where I'm going to give another caution. That's my job as a teacher, to give you some warnings. Don't type in this full number. Please, please, please don't type in this complete number. You only had 3 numbers here, 3 significant figures. And as a result, your answer is not going to be all that accurate. I'm not sure you can even determine energy of a wavelength this accurately. You're going to be wasting graphite, you're going to be wasting your time, and you might even copy it wrong. So all you've got to do is spend just a little bit of time, 3.52. That's all you needed, 3 significant digits. And that's true for most of the answers, except for calculations using lab data. So here I rounded off, 3.52. You could have written down 3.51 and gotten credit for it just as well, or even 3.53 if you wanted. And then I put in times 10 to the negative 19 joules. A low number, that's what you'd expect for the energy of a single photon. If this was a mole of photons, we'd end up having kilojoules worth of energy, but this is it. So on our caveat, be very careful using the scientific notation on the 30x's when they use this times 10 to. I didn't have to worry about parentheses here because it's all multiplication. But if you're doing a mixed calculation, multiplications and divisions, use parentheses around this because you could really mess up on it. That's our warning. It's a nice calculator. It's efficient. Just be a bit careful with this times 10 to. Their logarithm stuff is interesting too, but we'll get to that when we do our pHs. I was really surprised to see how their logarithms work, and I'll have a separate video on how to do logs using these TI-30s. All right, hope that helps. Musk luck saying goodbye.